Hi, this is Cora Stack again. I'm still on a roll with my trying to explain the mathematics behind Ireland's PR-STV voting system. So let me try again here, and perhaps this we'll attack it this way. Ireland does not use a simple first past the post voting system, as for example is used in England. Instead, we use PR-STV, proportional representation by the single transferable vote. This means voters do not choose one candidate, they rank candidates in order of preference. You put 1 beside your favourite candidate, 2 beside your next choice, 3 beside your next choice, and so on. But what actually happens after the votes are cast? So a lot of people don't really understand this, so let me try and see, can I help explain it a little more clearly? How is the winner decided? What is a quota? What is a surplus? And how can a candidate sometimes be elected without reaching a quota, for example, as happened in 2 elections in Ireland recently? In this video, I will explain the mathematics behind PR-STV system, hopefully in a clear and logical way. So PR-STV stands for proportional representation by the single transferable vote. So that's STV, the single transferable vote. The key idea is this: each voter has 1 vote, but that vote can move from one candidate to another as the count progresses. This is why it's called a transferable vote. Your vote may transfer if your first choice candidate is either, number 1, elected with more votes than they need, so that candidate has what's called a surplus, or eliminated because they cannot win. So your ballot can continue to influence the result through your later preferences. This is one of the most important democratic features of PR-STV. Part 2, valid votes, invalid votes, and non-transferable votes. Before the count begins properly, ballot must be checked. A valid vote is a ballot paper that can be included in the count. Usually a ballot is valid if the voter has clearly marked a first preference, that is, if they have put a clear 1 beside one candidate. A voter does not have to mark every candidate. For example, if a voter only marks candidate A1 and leaves the rest blank, that is still a valid vote. But an invalid vote, sometimes called a spoiled vote, is different. It may be invalid if, for example, no candidate is marked in an empty blank ballot. 2 candidates are marked number 1. The voter's intentions isn't clear. The ballot contains identifying marks, so the ballot paper is not officially authenticated, and the invalid vote is not included or not counted at all. But a non-transferable vote is not the same as an invalid vote. This is a very important distinction. A non-transferable vote was valid at the start, but later in the count it cannot move any further because the voter has not marked another usable preference. So it can be valid at a particular point, but at a later point it becomes non-transferable. A non-transferable vote was valid at the start, but later in the count it cannot move any further because the voter has not marked anything, another usable preference. So it can't be transferred at that stage. For example, suppose a voter marks only candidate A1. If candidate A is later eliminated, then the voter has not marked a second preference, that ballot cannot transfer to anybody else. So that's a very clear example of a non-transferable vote. It becomes non-transferable. So the distinction is invalid vote, not counted at all. Valid vote, counted at least as a first preference. Non-transferable vote, counted earlier, but cannot transfer further. This matters because the quota is calculated using the valid poll, not the total number of ballot papers in the boxes. The quota. So we talked about this before. So the quota is the number of candidates normally needed to be elected. Sorry, the number of votes a candidate normally needs to be elected. So there's a formula, a mathematical formula, and the formula actually, I didn't know this, it's called the Droop quota. The formula is just a very simple formula. It's something divided by something else plus 1. So quota is the valid poll divided by the seats, the total number of seats in the constituency plus 1. That's the denominator, the number of seats plus 1, and then you add 1. In plain English, take the total number of valid votes, divide by 1 more than the number of seats, add 1 to the number of seats, ignore any fraction, then add 1. So in a one seat by-election with 10,000 valid votes, we're just taking this as just a simpler example, then if that was the number of valid votes, so we have taken away the number of invalid votes, to determine the quota in a one-seater election, the 10,000 is divided by 1 plus 1, which is 2, which is 5,000, and then you add 1. So the quota for this particular simple example would be 5,001. This means a candidate normally needs 5,001 votes to be elected. So if a candidate gets that, say, on the first count, they are deemed straightaway elected. In a 5-seat constituency, for example, with 50,000 valid votes, the divisor would be 5 plus 1, which would be 6. So it would be 50,000 divided by 6, which is 833.33. Ignore the fractions and you get 8,333 add 1. So the quota is 8,334. The quota is lower in a multi-seat constituency because several candidates are being elected. In a 5-seat constituency, a candidate does not need more than half the vote. They need enough support to secure one of the 5 seats. So that formula is very important, and how it's determined. So for the moment, we'll just tell you what it is. It's the total number of valid votes divided by the number of seats plus 1 in the nominator, and then you add 1 to get the quota. So in a 5-seat constituency, a candidate does not need more than half the vote. They need enough support to secure, they need 1/6 of the valid vote plus 1. So why the quota works. The quota is not an arbitrary number. It has an important mathematical purpose. It ensures that this is the point, it ensures that no more candidates can reach the quota than there are seats available. So it's very clever, very clever. For example, in a 5-seat constituency, the quota, as I said earlier, is just over 1/6 of the valid poll. This means 6 candidates cannot all reach the quota. So the quota protects the proportional structure of the result. So that's very clever. That's very clever, in my opinion. So what happens in a 1-seat by-election? So in a 1-seat by-election, there is only one vacancy to fill, as we saw last week. Voters can still rank as before, the candidates 1, 2, 3, and so on. The count is ultimately looking off in a 1-seat by-election for one winner. In this setting, PR-STV works a little like a ranked runoff. If no candidate reaches the quota on the first preferences, as we saw in both of these, on the first count, the quota on the first count, the lowest candidate is eliminated. The votes are then transferred to the next available preference on those ballot papers. So let's use a simple example. There are 10,000 valid votes. We'll just go back to our simple example. The quota is 5,001 because there's a 1-seat constituency. 10,000 divided by 1 plus 1 is 5,000 plus 1 gives you the quota for this very simple case. The first preference are, we had this before, we're taking the very simple example, candidate A 3,800, candidate B 3,100, candidate C 2,000, candidate D 1,100. So no candidate has reached 5,001. So candidate D, the lowest candidate, is eliminated with the 1,100 first preferences. So that's what happens at the end of the first count in this particular artificial simplified case using 4 candidates. So candidates D's votes are transferred according to the next preferences in each of candidates D's pile. Suppose they just transfer like this. Supposing 200 go to candidate A. So you go down the list and candidate A appears in the next preference 200 times. Candidate B appears 600, so 600 to candidate B. So candidate B is the second preference. It would be the second preference here. Candidate C 200 and 100 non-transferable. So a non-transferable would mean that that none of them, there's just a 1 and nothing else for that particular example. The new totals are then, so 200 goes to candidate A, so we add that to the previous candidate A. So candidate A's votes now go to 4,000, and we're doing 600 to candidate B. So he moves up to 3,700, and candidate C moves up to 2,200 because we're adding 200 to candidate C. So no one reaches the quota on the second count here because the quota is 5,001. Still, no one has reached the quota. So the lowest remaining candidate is eliminated next. The process continues until a candidate reaches the quota or until only one candidate remains who can win. In other words, there's two left in the race. Can a candidate be elected without reaching the quota? Yes, sometimes near the end of the count, as we saw the quota is the normal route to election, but a candidate can sometimes be elected before reaching the quota. This usually happens near the end of the count, as we saw in both elections last week, when there are no further transferable votes available and no other candidate can overtake the leading candidate. For example, suppose the quota is 5,001. Near the end of the count, the totals are candidate A 4,900, candidate B 4,500, non-transferable vote 600. The total is 10,000. Candidate A has not reached the quota, but if there's no more left to transfer, nothing. And candidate A is ahead of candidate B on this count. Then candidate B cannot overtake or leapfrog candidate A. Then candidate A may be elected. This does not mean the quota has been ignored. It means the count has exhausted the available transfers and the leading candidate is the only candidate capable of filling the seats. So let's look at multi-seat constituencies then. In the general election, most all constituencies elect more than one TD. A constituency may return 3, 4 or 5 TDs. This changed the count because several candidates can be elected. In a 5 constituency we had already with 50,000 valid votes, for example, we determined the quota was 50,000 divided by 6, and then you ignore fractions, then you add 1. So we got 8,334 for a quota. Any candidate who reaches 8,334 on the first count is elected, but the count does not stop there. In multi-seat constituencies, the count usually involves 2 main mechanisms. The first one is surplus transfers, and the second one is eliminations. A candidate who receives more than quota, so in a 1-seat constituency, if somebody reaches a quota, that's it. They just win on the first count. But this is in the second seat, in multi-seat constituencies, that may not be the case. So we in both of the cases that we looked at previously, the quota wasn't reached in the first count in the 1-seat constituencies. But if either candidate, for example, in the Galway or the Dublin by-election had reached the quota in the first count, that was it, because none of the others could catch up with him, no matter how, in the system. So they would have just won it in the first count. So that would have been, well. So surplus transfers elimination. A candidate who receives more than the quota is elected and may have a surplus distributed. You often see this, as we said earlier, with Taoiseachs or very popular ministers, etc., or very well-known candidates and so on. You often see this. So if no one reaches the quota and there is no surplus to distribute, as we had earlier, the lowest continuing candidate is eliminated. The votes are then transferred. The process continues until all seats are filled. So let's look at what is a surplus. Surplus is the votes above the quota. A surplus happens when a candidate receives more votes than they need to be elected. Suppose the quota again is 8,334. Candidate A receives 10,334 votes, for example. Candidate A is ahead. The surplus is the number of votes minus the quota, so it's 10,334 minus 8,334. So this gives a surplus of 2,000. The principle is simple. Candidate A keeps the quota needed for their election. The surplus value may transfer to any candidates according to the next available preferences on the relevant ballot paper. So these prevent excess support from being wasted. So this is a very important concept also, the transfer value. So the transfer value is the surplus divided by the transferable votes. This is one of the most important mathematical ideas in PR-STV. When a candidate has a surplus, not all of their votes move on at full value. Only the surplus is transferred. So to do this fairly, each transferable ballot is assigned a transfer value. So this is one of the most interesting concepts, in my opinion. So the formula is the transfer value is the surplus divided by the number of transferable votes. The key point is this: the denominator is not always the candidate's total vote. It is the number of transferable votes in the relevant pile. This means ballot papers that have no next available preference for a continuing candidate are not included in the transfer calculation. Let's take an example. Suppose the quota is 1,000. Candidate A receives 1,200 votes. Their surplus then is 1,200 minus 1,000, which is 200. But supposing only 800 of candidate A ballot papers have a next available preference for a continuing candidate. In other words, there's just a 1 and nothing else. Then the transfer value is 200 divided by 800. Not 200 divided by, it's 200 divided by 800. So, and that equals 0.25. So each of these 800 transferable ballots moves at a value of 0.25. So the total value transferred is 800 times 0.25, which equals 200. That ensures that exactly the surplus transfers, no more and no less. So let's do a worked example. So let's look at a larger example. Candidate A is elected again with 10,334 votes. The quota is 8,334 votes, so the surplus is 2,000. Next, suppose the next available preferences on candidate A relevant ballot paper are. So this is the key point. These are the ones that are multiplied by the transfer value. So the next available preferences on candidate A ballot papers are candidate B 4,000, candidate C 3,000, candidate D 2,000, candidate E 1,000, non-transferable 3,034. The number of transferable papers is 4,000 plus 3,000 plus 2,000 plus 1,000, which is 10,000. The 334 non-transferable papers are not included because they do not show a next available preference for a continuing candidate. The transfer value is 2,000 divided by 10,000. This equals 0.2. So the surplus is distributed like this. So you take candidate B, his paper is 4,000, you multiply by 0.2, you get 800. You take candidate C, 3,000, multiply by 0.2, get 600. Candidate D, 2,000, multiply by 0.2, that's the transfer value, equal 400. And candidate E, 1,000 transfer value, multiply by 0.2, 200. The total transferred is exactly 2,000, and that ratio, the transfer ensures that sum adds to 2,000, and this is the surplus. The important lesson is that